Hello everyone, welcome to Applications Manager free training series in multi-cloud infrastructure monitoring. Let's jump into today's agenda. We are going to cover overall four topics, and in the first topic, we will discuss how to track the performance across your cloud application. In the second topic, we will explore how to gain end-to-end visibility in your serverless application. In the third topic, we will discuss how to track the critical KPIs across your container orchestration platforms. Lastly, we will discuss how to address performance issues and improve the efficiency of your cloud environment. In the recent days, we have witnessed the introduction of new technologies that have led us to adapt to the cloud environment. As per the recent Gartner forecast report, approximately 94% of enterprise users have moved to the cloud technology, which contributes to the market value of $600 billion. And the estimated market value by the year 2025 is projected to be around $833 billion. So the main transitioning to the cloud helps us in achieving better scalability, cost efficiency, faster deployment, and enhanced security. Also, the global distribution of cloud services in data centers allows businesses to expand in different regions and business benefit customers with low latency. If we started adapting to these technologies, it is crucial to ensure and monitor the performance of cloud applications, which is the focus of our first topic. In Applications Manager, we monitor in complete packages. When I say it is a complete package or bundle, for example, in Microsoft Azure, we only monitor a set of top services that have been hosted within your Microsoft Azure platform. And the same applies to all other cloud platforms as well. How we are monitoring your cloud applications or containers using Applications Manager. As you might all know, to monitor your complete infrastructure, Applications Manager functions as an agentless monitoring tool. And the same applies to the cloud environment as well. So we will be using certain API requests for fetching the information from different cloud sources. For Amazon, the information is fetched via CloudWatch through API request. For Azure, the data is fetched from Azure Monitor. Likewise, different API request methods are used to retrieve information from various cloud technologies. Since Applications Manager is a agentless tool, we use metric aggregator, which plays a crucial role in fetching the information from the cloud source. So once the metric aggregator collects all the necessary information, it will deliver to the fault management phase. In this fault management phase, the system checks for any service downtime in a particular cloud and verifies whether any attribute or parameter incidents have occurred based on the configured thresholds. Upon identifying such incidents or downtimes in the fault management process, notifications are initiated in the form of email actions, or if any ticketing tool is integrated with the Applications Manager, then a new ticket will be generated on the designated help desk. This is the phase of fault management. On the other hand, the information gathered from the cloud by the metric aggregator is transmitted to the database for reporting and analytics purpose as well. So this complete process ensures effective monitoring of cloud applications and triggering alerts when necessary. And one of the most beneficial and beautiful part of this process is users can refer to the reports for specific attributes to improve the overall performance and analysis of cloud-based systems. When it comes to monitoring the services for AWS, we cover most of the top services, and here are the few services currently supported in Applications Manager that are hosted within your AWS environment. So in compute, we support EC2 Lambda EBS, so ECS, EKS under containers. For database, we support RDS, DynamoDB, ELB under load balancing, S3 buckets for storages, SNS for notification, SQS for queues, and billing also supported for accounting purpose. So with the help of monitoring the billing, you can track and analyze the usage cost of your services and understand where your money is being spent to establish budgets and forecasts for your cloud expenses as well. As I mentioned previously, we are using a set of APIs as cited on this page for each instance or service in order to fetch the information from the CloudWatch, which is hosted within your cloud environment. Okay. So now when it's come to the Azure monitoring, these are all the top services that are supported in Applications Manager. So under the analytics, we support setup analytics, Kubernetes clusters under containers, Azure Service Bus integrations, standard and premium storage accounts, and virtual machines under compute, and SQL databases, Postgres databases, MySQL databases. And when it comes to the network services, we support basic and standard load balancer. And here also the billing feature is supported in Azure. Okay. So when it's come to the Microsoft Azure, how we are discovering the monitors in your Azure platform. When it's come to the Azure discovery, we use three modes of data collection to fetch the data from your Azure environment. The first mode is AD application and service principal. In this mode, the specified user has to create a AD application in the Azure portal and provide the client credentials. So once the client credentials and the secret ID has been given, this discovery can be done. In the second mode of discovery, if you have your Azure organization account, then by providing Azure credentials like the mail ID and password, by using the credential AD application will be created and its client credentials are fetched using the PowerShell scripts. Further, in this case, if you are using a OAuth in Azure, you can use the same OAuth credentials in Applications Manager in order to establish a secure connection during every data collection cycle. So, as I mentioned of these three modes of monitoring, any one mode of monitoring is enough to complete the Azure discovery. When it comes to monitoring the Microsoft 365 services, here are the services currently supported in Applications Manager. We support Exchange Online, SharePoint Online, and Microsoft Teams as well. With the help of monitoring the Microsoft 365 cloud in Applications Manager, we can see the overall health and performance of your Office 365 in a single dashboard, proactively monitor the users and license details, comprehensively monitor your Exchange Online servers, tracking the critical SharePoint metrics, and with the help of tracking the critical SharePoint metrics, we can analyze and fix the performance issues rapidly. Now let me take you to the App Manager user interface and demonstrate how we can perform the discovery process and how the data will be displayed. This is how the Applications Manager user interface console looks like. So under the new monitor, add new monitor. So this is how the add monitor page looks like. On the left side, we have categorized upon technologies. Now I'm going to discover a Azure monitor. So under the cloud applications, I'm choosing Microsoft Azure. So these are the three modes of monitoring that we discussed previously. So let's assume here the AD application and service principle we are going to use. So these prerequisites should be completed before adding into Applications Manager, where you need to create the Microsoft Enter application, get the application's IDs like the tenant ID, client ID, and the client secret key. Further, after assigning the role, the prerequisites has been completed. Now you can go to add monitor. So these are all the informations need to be given. The first one would be the display name. This can be given as per our reference. The subscription ID, Azure services. So in this Azure services, by default, all supported services will be mentioned over here. For example, let's say if you want to discover only a specific Azure service. So in that case, you can choose that specific services. Here I just chosen the virtual machines over here. So after choosing the Azure services, you can mention what is the account type, whether it is a global account or the government account. Now, once after choosing this, here we have the discovery mode. Under the discovery mode, as we completed the prerequisites for the AD application and service principal mode, we can give this necessary details. Once after that, child monitor discovery. So what action you want applications manager to take? So whether you want to discover the services and currently stop the data collection to get into unmanaged state, or you want to discover and monitor the entire infrastructure services, or you want to discover and monitor based on the rejects filter. Now, what is this rejects filter? So let's assume you have 100 of virtual machines. So, but as per your requirement is to discover only 30, 35 virtual machines only. So in that case, using this rejects filter, you can give the criteria to discover only those required virtual machines into applications manager. So once it is done, you can choose action on deleted resources. Now, what is this option? So let's assume you have discovered 100 virtual machines into applications manager and everything is working fine, the data collection is working. But suddenly, one of your cloud admin is going to delete a 10 of the virtual machines. In that case, what action you would like applications manager to take? Whether you want to continue the alerting for the resource, whether you want to stop the alerting, or you want to unmanage the resource, or you want to delete the same resource in applications manager as well. So once after giving all the necessary details, monitor will be available. So under the monitors tab, category I'm choosing. So under Microsoft Azure, this is how the monitor will looks like after adding. So in the overview tab, we will list out all the services and components that is running on your Azure environment. And under the compute tab, all the discovered virtual machines, VM scale sets, functions, Azure app services that are currently available in your environment will be discovered and shown like this. So in case if you want to drill down a specific virtual machine, just click on the specific virtual machine here over here. So I'm just clicking on it. So under this virtual machine, we can see the complete usage details like the CPU usage, memory usage, like how much, what is the available memory, used memory, and the used swap memory as well. And under the disk, if I scroll down to the bottom, I can see what is the available disk and what is the status and health of the disk. So if I want to configure alarm, I can configure in order to get alerts as well. So what is the network usage and what is the configuration of that virtual machine? So the system information, the OS information, in what are all the network that is used by the virtual machine. Those details, those drill down details can be found under the virtual machines. So after that, after the virtual machines, let me explore other tabs as well. So here we have the database tabs. So under the database tabs, what are all the databases that are currently available on your Azure environment will be discovered. Like the currently in this environment, we have the Cosmos DB, MariaDB, MySQL DB, Postgres DB, and Azure SQL databases. As an overview, we will show the database name, in which resource group it was associated, what is the database location, what is the status, and the database usage and its health. So if you want to configure alarm for any of the attribute, we can do that. So now I want to drill down into the specific metrics of my Azure SQL DB. Just clicking on the specific Azure SQL DB, it will take you to the user interface. So now you can see the top running queries and the top queries by the IO and the top CLR queries and the top slow running queries as well. So you can generate report and share it with your DB team in case a particular, if you found any particular DB is blocking or hampering the performance of your database as well. So what is the most blocked queries? And if you want to configure any alarms, we can configure the alarms as well. So this is under the database level. So now we will check on the, okay, now we can move on to the storage tab. So under this storage tab, you can view the status of your available storages. And if you like to drill down into any specific storage, we can do that. Here we can say the see the blobs details, table details, file details, and the queue details as well. So these are all the details that we monitor in Microsoft Azure. Now I will take you to the Microsoft 365. Same like under the cloud apps by searching on the Microsoft 365. So these are all the prerequisites we need to complete. So once after the prerequisites has been completed, we can, by giving the credentials, the discovery will be completed. Now I will showcase the monitor data in Microsoft 365. Okay. So same like it will be, I'm just, so we use the Grab API, which is recommended for from Microsoft in order to uh, collect the data. So under the usage tab, we can see the complete usage of your Microsoft 365 and what are all the usage report collected date. And as a pictorial representation in a pie chart, we can see how many active users are in there and how many inactive users are in there. Same like in a bar chart view also. So in the bar chart view, we can see the services details over here. And in the table details, these are all the services that are currently available within the Microsoft environment, and these are the users that are active and inactive. So in case if you want to configure alarm, here also we can configure the alarm as well. So these are all the overall details can be fine. So if you want to specifically drill down into the Exchange Online, so by clicking on the specific Exchange Online, we can see the complete usage details of it. So what are the site storage usages and the total storage usages and the split down of the complete file usage, site usage, and the unique files as well. So if I want to get any reports for any of the data, we can get the reports as well. And adding to that, if you want to check what are all the sites and applications that are currently available, we can find the complete details of it. So here it is showing the site URL available and what is the storage and what is the free storage and currently in which status it is and the total files. Those details can be identified over here. And if you want to configure alarm, we can configure the alarm as well. Same applies to the SharePoint as well. So likewise, like the Exchange Online, we can see the complete usage details of your SharePoint application and what are all the sites and applications that are running in it. And also we can drill down into the Microsoft Teams as well. Okay, so now let me move on to the next topic. So now let's dive into the second topic. Previously we discussed how to track the performance across your cloud application. Now we will explore how to achieve end-to-end visibility for your serverless applications. We talk about applications. There are two types of architectures available: monolithic architecture and microservices architecture. Now, what is a monolithic architecture? Just visualize you have multiple applications hosted in a single application server. In case any one application goes down or has a problem, what action you you want to take? So you need to restart the entire application server in order to fix that specific component. Now, with the help of microservices architecture, each application has its own microservice. If there is any issue, you can just restart the specific application and there is no need to restart the entire server. So nowadays, for faster deployment and improved performance, we have started adopting to this microservices architecture. We talk about serverless monitoring in Applications Manager for Amazon. We use a function called AWS Lambda, and in Azure, we have the Azure functions. Now, what exactly serverless monitoring do? With the help of serverless monitoring, You don't need a separate server or allocate a separate resource for your application or web server to handle all those technical details. If you have your code ready, you can simply deploy it on your AWS Lambda or Azure functions. It will automatically manage the components and you can choose the operating system you want or select specific components without manual allocation. So you need to just upload your code for execution and it will provide a link for accessing your application. However, when using AWS Lambda and Azure functions, it is important to ensure that your code works well in the Amazon or Azure environment. This is where the concept of serverless monitoring comes in. Let me quickly take you to the user interface and show what serverless monitoring looks like. We are back in the applications manager UI. So for AWS, I'm going into the Amazon AWS to see the Lambda functions. Under the compute tab, we have the Lambda function. So as a overview of the Lambda, it will display the function name, the region, and what is the version, what is the runtime, and what is the code deployed size, and its timeout, and the last modified time as well. And if we need to configure any alarm, we can do that. And also the each application mentioned here are named as function. So function is nothing but your piece of code of your application. Now I want to drill down into the specific function to see how your code behaves. So when it comes to the lambda details, we can see what is the state, what is the invocation rate, and when it comes to invocation rate, we can drill down into the success rate, error rate, like the current concurrent executions, provision concurrency, and what is the duration that is taking for the code execution. And these are all the details can be able to see under the code level serverless monitoring for AWS Lambda. When it's come to the configurations, we can see what are all the configuration details associated for your serverless monitoring. So for this specific AWS Lambda, we have these types of configurations. And when it's come to the resource details, the memory size that is taking is 512, and the code deploy size is this much, and the timeout is this much. Apart from this, we have the function details and the security and network details as well. So this is how the serverless monitoring looks in Applications Manager. So now can move to the next topic. Now we are in the third topic. Previously, we discussed how to achieve end-to-end visibility of your serverless application. Now we will explore how to track the critical KPIs across your container orchestration platforms. So in Applications Manager, we do support monitoring for Docker, Kubernetes, and OpenShift containers as well. Now, why container monitoring is very important? With the help of container monitoring, we can ensure the availability and performance of your container, scale your specific applications effectively, identifying the issues quickly, ensuring security components, and optimize the costs as well. In Applications Manager for OpenShift, we automatically monitor these KPIs cited on this page, like the node details, pod details, containers, services, and jobs. Now, how to discover your OpenShift in container platform using Applications Manager? There are two ways to do this, the SSH method and the Prometheus method. The first method involves using a SSH connection. If you have SSH connectivity to OpenShift machine, with the help of OCL command, we fetch the necessary information. So this process is initial step of discovery. For the second method, we recently introduced Prometheus integration. In earlier version of Applications Manager, we only supported the Prometheus integration for discovering Tomcat. However, in the most recent versions, we have expanded this support to include discovering OpenShift as well. For security reasons, if you are unable to establish the SSH connection to fetch the OpenShift data, such as executing OCL commands, now you have the option to integrate Prometheus directly through the exposed Prometheus API to fetch the information from respective OpenShift environment without the need for a SSH connection. So now I will take you to the user interface and demonstrate how to discover those containers. So to discover the container orchestration platform, I'm just getting into the monitors tab, new monitor. Under virtualization, I'm choosing to discover the OpenShift. So before adding the OpenShift using the SSH method, so currently we are going to discover the OpenShift using the SSH. So on the right side, we can see the help card over here. So in this help card, we have mentioned the prerequisites that has to be completed before adding. So once we make sure these prerequisites are completed, we can give the credentials to add the monitor. So the first one will be the display name and the host name and the IP or the IP address. And after giving the username, password, and the SSH details, so we use here we use the REST API method in order to collect major metrics as well. So after giving the username, password, so you can test the credentials and complete this discovery. So this is how we can discover using the SSH connection. Now I will take you to the user interface. So before we going to the user interface of OpenShift, I will show you how to discover the same using the Prometheus method. Under the settings, add-on settings, let it be load. Meanwhile, I will take you to the user interface. On the other hand, okay, category view. Under category view, virtualization, OpenShift. Settings, add-on settings. Okay, not a problem. So this is once after completing the discovery, this is how the OpenShift container will look like. So under the overview tab, we will showcase the complete details of your OpenShift. Under the project tab, we will showcase the status of your current project available on your container. What is the project name and what is the project status and from which time it was created. So according to any of the attribute as per your requirement, you can configure alarms as well. Now under the node details, we can able to see the top five nodes and the top five nodes by memory details and the CPU details as well. So here are all the some expanded details along with the node memory and CPU memory. Like what is the name of that and what is the allocated process count, CPU limit, CPU request. Those kind of details will be available over here. This is for nodes. Similar to that, the port details, we can see the complete structure details here. So like the port name and what is the project it was associated and for which what is the port type and what is the IP address of it and currently what is the status of that port, whether it is running or pending or succeeded, and as well the start time and the created time as well. So according to any of the attributes, we can configure alarms as well. So if we scroll down a little bit, we have the bar chart view that shows the top 10 ports by the CPU details that are consuming and the same memory details consumption that are taken by the 10 ports as well. We can under if you scroll down, we can see the table details of this complete port. So what are all the containers that are available? So top five containers by restart count, we will showcase the top five. That same data will be available format. And if you want to configure alarm, we can do configure alarms as well. So under the service tab, if there are what are the services that are running, what are the deployment details can we find. So under the job details, so what are jobs that are available on your cloud environment and what is the successful replica, is that replica and the project name, start time. These details can be find under the job details as well. So this is how the container data will be monitored. So as I mentioned about the Prometheus, so under the add-on settings, we have this Prometheus monitoring. So if, as I mentioned, there are two types. So if you are unable to establish a successful SSH connection, you can use this Prometheus integration. So where it won't require any SSH connection. So as we are using this expose Prometheus UPI. So however, for Kubernetes and Docker, currently only the SSH mode is supported. We are working on adding more monitor types in the Prometheus integration to enhance the monitor capabilities in the upcoming days. So under the general specifications, you need to provide the display name, polling interval, and the expose API. After providing the host name, port, endpoint URL, and HTTP details, here we are having three types of options. The first one would be the monitor type, as I mentioned. These two monitors types are supported. We are just choosing the OpenShift. Under the discovery option, what action we would like to have from the applications manager again, whether you want to pass the discovery, we want to discover and continue the monitoring, or we want to just discover and do not monitor the resources, or we want to specify any specific instances to be discovered. So once after choosing those necessary details, here we have the action on monitor if the node data is available. So what action you want to take if any data that is not available within the container resource, whether you want to mark that monitor as down, or you want to unmanage a monitor, or you want to delete the specific monitor. So once after providing all this information, the discovery will be completed. So this is for the container level monitoring, and the same OpenShift details that I shown over here will be applied to the Kubernetes and Docker as well. Now let's jump into the final topic. Previously, we have discussed how to track your critical KPIs across your container orchestration platforms. Now we will explore how to address performance issues and improve the efficiency of your cloud environment. In Applications Manager, we have automated actions designed to simplify tasks. For example, let's take you have more than 100 virtual machines in your environment, and a few virtual machines unexpectedly goes offline. So instead of manually logging into the Azure portal to restart them, you can make use of the automated action option to restart the specific Azure virtual machine or Amazon EC2 instance. So which is going to be currently in the down status, so that are able to restart with the help of Applications Manager. So by doing this, you can eliminate the need of manual assistance. Further, in a cloud environment, it is crucial to ensure that you stay within your cost limits set by your management. Since cloud costs can highly fluctuate, the Applications Manager help you to keep track of these expenses regularly by using the billing information feature. With the help of this billing information feature, you can monitor and ensure the cloud cost in both Azure and AWS environment to stay within your allocated budget for specific services. Now, to prevent service outages, proactive monitoring is crucial, where we use a threshold profile and the anomaly concept that allows you to set values to receive an alert if any metric exceeds that value. Additionally, we have integrated machine learning into monitoring, which means you can establish a baseline limit for potential spikes in various attributes such as memory or pod utilization on your cloud environment. So the machine learning system alerts you if any spike occurs. As we discussed before, we have four automated actions, including a restart option and the ability to execute a certain program. So if any services goes down, you can use these automated actions to restart the specific service to provide a practical solution. Now, when it's come to performance monitoring of your cloud applications, I believe in the second part of our training series, our expert covered something called APM Insight. So this feature helps you to track of complete application on your AWS Beanstalk. So it will monitor the entire end-to-end real-time transactions performed by the users. So by using APM Insight, you can keep a close watch on the performance and quickly figure out where in your code or function there might be errors. So this way you can catch and fix issues before they become major troubles with the help of this performance monitoring. Now let me take you to the App Manager user interface for demonstration. Okay. So now as I talked about the available actions, so these are all the actions that are available. We have the email action, SMS action, and with the help of here we can see the execute program option. So with the help of this execute program action, you can write a script to restart a specific service and execute that script from applications manager to perform the any specific action. And also in case if you are using any third party tool for ticketing purpose, then you can send a trap using this trap action. And along with that, with the help of the if you have a service now or manage engine services plus, you can integrate it with applications manager. And if something went wrong, the ticket will be created on the designated help desk. So here we have the cloud action. So we can restart the VMs for Azure and EC2 instances for AWS, and by creating and we can associate any specific action. So I will showcase how it works. So under the cloud option, this is for Amazon. You can give a display name. After giving the display name, what action you want to take by associating this action. So whether you want to start the instance, stop the instance, or restart the specific instance. So here we can specify according to our requirement whether this action to be done from a specific monitor group or a specific monitor or a specific EC2 instance. So after selecting these types of details, if we're choosing monitor group, definitely we're going to choose the monitor group as well. So we can mention the emails also. So once after the action has been triggered, so for which email you want to associate in order to get notified, and in what are the times you want this specific action to be triggered. So whether you want to execute this action outside your business hour or inside your business hour. So after you have created the business hour, you can associate it. The same applies to the Azure as well. So in Azure, we can restart, stop, or start the virtual machines as well. The same like the cloud action, we have the container action as well. So in this container action, we can identify what action we need to perform on our container. So where we want to start, stop, or restart the container. So after choosing these types of details and the agent monitoring group, these details can be associated. So apart from these actions, we have the Windows service actions as well. So here, with the help of this Windows Service Action, if you are using a third-party ticketing tool, and that suppose the REST API, then with the help of Webhook REST API, you can integrate it with Applications Manager and log a ticket automatically. So this is how, or this is the actions that are available. So now we will go into the APM Insight feature. Under the APM Insight tab, we can see the supported technologies. If we scroll down a little bit, we can see the performance monitoring that can be achieved using the AWS Beanstalk. So once the applications that are hosted within your cloud environment are added for monitoring after completing this agent deployment and the prerequisites, it will be available. So as it is a real-time performance monitoring, we can able to identify the performance bottlenecks over here. So let me show you. So let's assume this is one of the application that is hosted within your cloud environment, and these are all the crucial metrics that we monitor. So under the aptech score, so this aptech score will be calculated based on the overall performance of your application within the response time. So by identifying this aptech score, we can see how our customers are feel when trying to access the application, whether they are satisfied, tolerated, or frustrated. So these data that are currently available here are captured within the last 30 minutes of the transactions. So when this comes to response time, it will showcase the overall response time and how many requests that are went in, uh, come into our applications, and what is the data that is taking and what is the exceptions that are available. So if we scroll down a little bit, we can find the top 5 transactions that are taking more response time. As it is a demo application, it does not have that much of data. So let me try to pull over here. Okay. So this 5 transactions are taking more response time. Now I want to drill down into the any specific transaction. I can go inside the transaction to see which trace is causing the exact uh, exact slowness. So here for this specific transaction, we have this specific trace. So if there is no slow traces, it doesn't mean the DB queries might running behind the application might have the slowest method calls. So by clicking on the traces tab, we can see what are all the code stacks that are available here. So under the transaction, we move to the traces tab, find the code level stack. And under the database tab, we can see by sorting out, we can see what are all the average response time that is available over here. Same like this is one of the major feature we have, which is called the service map over here. With the help of this service map details, we can see what are all the components that are associated within the applications. And as you are using a cloud environment, you may have the multiple components associated as a microservices. In that case, all the details and the components will be shown over here. So currently for this application, this specific PG component as external component is over here. So by hovering to that specific component, we can see the average response time, what is a failed request and the total requests that are giving. So totally in an overview, a complete health of the external component can be achieved over here. And under the app parameter, we can see what are the app parameters that are available for Java applications. Currently, the JMX parameters will be available for monitoring. If you want any specific parameters to be monitored, we can add that into Applications Manager. So now let me move on to the reporting. So under the reports, we have the capacity planning report. I will showcase. So what is this capacity planning report? So with the help of this capacity planning report, we can easily identify the highly loaded, undersized or oversized or idle servers as well. So I'm just choosing the OpenShift undersized over here. So when it's come to the undersized server for OpenShift, each and every node will be allocating the CPU. So which will help the capacity planning report. You can analyze whether the particular allocated CPU is sufficient for the specific node or not. If it is not sufficient, it will show as red. So currently it is in green status. So once after that, you can able to decide whether you want to allocate any additional component for your container environment. So apart from this capacity planning, we have the forecast report as well. So when it's come to the forecast report, I'm just choosing for servers. We can identify like what is the current utilization and what will be the future utilization of a particular service. Once after identifying the pictorial representation of the complete capacity report and the forecast report, we have the custom reports based on the monitors. So if we want to share any specific reports with our management under the cloud apps, We have the under the select metric, you can have all the metrics available within your cloud environment. So by clicking on a specific metrics, the report will be generated using the any custom time period, and we can share. So by clicking on the health of the cloud apps, we can see the report. So currently it is not available. So we have seen the actions and the report details. Now I will show you the billing section, which is the cost management. So under the category view, I will showcase for the Microsoft Azure. Okay, this is the billing feature, which is going to be very crucial for the enterprise users. So here we can have the split among the daily expenditure and the billing summary. If you scroll down a little bit, we can see the bar chart representation and a table representation of what are all the top services that are costing more for for our environment. So in this demo, we can see the database PostgreSQL is costing more compared to the other services. So one of the thing here we have the benefit we have is we can configure alarms. So let's assume this for this specific Azure database for PostgreSQL, I don't need the spending to be goes or above 400. So in that case, I can create a 400 of a threshold value and configure alarm to get notified. Same like if I scroll even more, I can find the top 10 costs by the resource groups. So what are all the resource groups that are costing and which is spending a lot? So here we have this APM group. It is costing more compared to the other resource groups. Same like we can have a split up in the region wise as well. So here we can have the comparison of between ourselves. So compared to the US West and these types of region, the US Central region is have the highest spending. So which means the services that are running on the US Central have the are costing more compared to the other services running in other regions. So this is how the details of the complete cloud infrastructure will looks like in Applications Manager. Now let have a quick recap on today's session. So in the first part, we discussed about monitoring your cloud application. Then in the second segment, we discussed monitoring your serverless applications for Amazon and Azure. Moving to the third topic, we explored the critical KPIs and the container orchestration platforms for OpenShift. At last, in our final discussion, we learned how to identify performance bottleneck using APM Insight and Azure Billing as well. Thank you everyone for your valuable time and participation. Have a nice day.